Hi future GISPs. I'm going to teach you everything that I learned to easily pass the GISP exam so that you don't have to study the 210 websites, 1,155 book pages, 1,700 Quizlet flashcards, and 291 videos and podcasts included in the GISCI's recommended study material like I did when I passed the GISP exam. In this video, I'm going to teach you everything I learned about basic application development methodologies to easily pass the exam. Basic application development methodologies is the third section under the application development category of the GISCI's knowledge categories. Let's get started with section 803, Basic Application Development Methods. Application development methodologies are frameworks that provide a structured, repeatable approach to planning, designing, developing, testing, and maintaining software applications. These methodologies ensure that the final product is high quality, meets user requirements, and is delivered on time and within budget. A development methodology determines how a project is managed, how requirements are gathered, how teams collaborate, how testing is performed, how change is handled, how risks are mitigated, and how the final product is delivered. Most application development methodologies fall into four major categories: Waterfall, Agile, Rapid Application Development, and Spiral Development. Additional modern approaches include DevOps and DevSecOps. First, let's explore the Waterfall methodology. The Waterfall methodology is a rigid linear model consisting of sequential phases. Each phase must be fully completed before the next one begins, and changes late in the process are difficult and expensive. The waterfall phases typically include requirements, design, implementation, verification, and maintenance. Waterfall is easy to understand and manage, but is slow, inflexible, and not ideal when requirements change frequently. The requirements phase defines exactly what the system must do. All user needs, constraints, and specifications are gathered up front, documented, and finalized before development begins. The design phase creates the system architecture and technical blueprint. Developers plan how the system will be structured, what components will be used, and how data will flow through the application. The implementation phase is where developers write the actual code. The system is built strictly according to the predefined design without major changes. The verification phase involves testing the system to ensure that all components work correctly, meet requirements, and perform as expected. Any defects are corrected before deployment. The maintenance phase includes updates, bug fixes, improvements, and long-term support after the system is deployed. This phase continues throughout the life of the system. Waterfall methodology provides a clear, structured, and sequential development process that is easy to understand and manage. However, because each phase must be completed before the next phase begins, Waterfall is rigid and slow to adapt to change, making it best suited for projects with stable, well-defined requirements that are unlikely to evolve over time. Now let's take a look at Rapid Application Development, or RAD. Rapid Application Development is a condensed development approach designed to produce high-quality systems quickly with lower investment costs. Rapid application development is best suited for smaller projects with well-defined objectives and minimal technical complexity. It requires an experienced, stable development team. Rapid application development relies on prototyping, user feedback, and quick iterative design. Rapid application development consists of 4 main phases: requirements planning, user design, construction, and cutover. In the requirements planning phase, developers and stakeholders work together to define the system requirements, project scope, constraints, and objectives. This phase is brief but essential. The user design phase is highly interactive. Developers and users collaborate to build models, prototypes, and mock-ups of the system. Feedback is collected immediately and incorporated into the design. In the construction phase, developers rapidly build and refine functional components. Prototypes evolve into working modules. This phase includes programming, testing, and iterative refinement. Cutover is the final phase where the application is completed, tested, documented, and deployed. This includes final user training, data conversion, and system launch. Rapid application development is unique because the user design and construction phases repeat, often multiple times, until the product meets all user requirements. The constant feedback loop allows changes to be implemented quickly and ensures users are involved throughout the project. Now let's take a look at Agile development. Agile is an iterative, flexible development methodology where software is built in small increments called iterations or sprints. Agile emphasizes collaboration, continuous testing, and frequent delivery of working software. It is highly effective when requirements evolve over time. Types of Agile methodologies include Scrum, Crystal, and Extreme Programming. The Agile process generally includes requirements analysis, design, development, testing, deployment, and review. In the requirements analysis phase, teams collaborate with stakeholders to define user needs and create a high-level vision rather than a detailed upfront plan. In the design phase, design evolves gradually, allowing flexible decision-making during development. In the development phase, developers build small features in cycles, lasting 1 to 4 weeks, integrating and testing code continuously. In the testing phase, automated testing accompanies development to prevent new features from breaking existing functionality. In the deployment phase, working software is released frequently, sometimes daily or weekly, allowing early user feedback. In the review phase, sessions ensure alignment with user needs and allow adjustments throughout the project. The Agile phases, requirements, design, development, testing, deployment, and review, form an iterative cycle that delivers working software quickly, incorporates continuous feedback, and adapts easily to changing user needs. Let's take a look at Scrum methodology. Scrum is an agile framework that organizes work into fixed-length iterations called sprints, usually lasting 1 to 4 weeks. A Scrum team includes defined roles such as the project owner, Scrum Master, and development team. Work is planned in a backlog, and teams review progress through daily stand-ups and end-of-sprint reviews. Scrum emphasizes transparency, frequent communication, and continuous improvement. Now let's take a look at Crystal methodology. Crystal is an agile methodology focused on people, communication, and talent rather than strict processes or tools. It adapts to project size and complexity using different crystal colors, such as crystal clear or crystal orange. Crystal values team interaction, frequent delivery, and simplicity, allowing teams to choose the techniques that work best for them rather than following a rigid structure. Now let's take a look at the extreme programming methodology. Extreme programming is an agile approach centered on high-quality code and continuous improvement. Extreme programming uses practices such as pair programming, test-driven development, continuous integration, rapid releases, and constant user feedback. It is designed to reduce defects and adapt quickly to changing requirements through strong technical discipline. Now let's explore spiral methodology. Spiral methodology combines features of both waterfall and rapid prototyping. It emphasizes risk analysis and is ideal for large, complex, or high-risk projects. The process is broken into smaller segments called spiral traverses, where each cycle includes planning, risk analysis, engineering, and evaluation. The planning phase identifies project objectives, constraints, requirements, and alternative approaches. It establishes what the segment of the project needs to accomplish before moving forward in the spiral cycle. The risk analysis phase evaluates potential risks, uncertainties, and technical challenges. Teams analyze feasibility, identify high-risk elements, and develop strategies to reduce or eliminate those risks before continuing. The engineering phase involves designing, building, and testing a prototype or functional component of the system. This phase focuses on creating a workable version of the product that addresses the requirements and mitigated risks of the current cycle. The evaluation phase checks the prototype or deliverable with stakeholders. Feedback is gathered to determine whether requirements have been met, risks have been resolved, and whether the project should move forward to the next spiral cycle. Spiral methodology combines iterative development with formal risk analysis, making it ideal for large, complex, or high-risk projects. By progressing through repeated cycles of planning, risk evaluation, engineering, and stakeholder review, the spiral approach reduces uncertainty and ensures the project evolves safely and efficiently as risks are identified and resolved. This approach reduces risk by allowing repeated refinement and assessment throughout the project lifecycle. Now let's take a look at DevOps development methodology. DevOps is a modern development methodology that emphasizes collaboration between development, quality assurance, and operation teams. DevOps focuses on automation, continuous integration, continuous deployment, and rapid delivery of software updates. The DevOps cycle includes planning, coding, building, testing, releasing, deploying, operating, and monitoring. The planning phase defines project goals, requirements, tasks, and development priorities. Teams align expectations and create a roadmap for upcoming work. In the coding phase, developers write and update the application's source code. Version control systems track changes, support collaboration, and ensure code integrity. The building phase compiles and assembles the code into executable components. Dependencies are resolved, and automated build tools verify that the code can run properly. In the testing phase, automated and manual tests are executed to identify defects, verify functionality, and ensure code quality. Testing happens continuously to prevent issues from reaching production. The release phase prepares the validated application for deployment. Approved builds are packaged and staged for rollout, while ensuring compliance and readiness. In the deploying phase, the application is moved into the production environment. Automated deployment tools help ensure consistent, reliable delivery with minimal downtime. The operating phase involves running and managing the live application. Operation teams monitor performance, manage resources, and keep services running smoothly for users. Monitoring collects performance data, logs, and user feedback to identify issues, resolve incidents, and guide future improvements. Continuous monitoring drives proactive system health management. The DevOps methodology unifies development, testing, and operations into a continuous collaborative cycle that delivers software faster, more reliably, and with higher quality. By emphasizing automation, continuous integration, continuous deployment, and constant monitoring, DevOps reduces delays, improves system stability, and ensures that updates reach users quickly while maintaining a high level of performance and reliability. Now let's take a look at DevSecOps methodology. DevSecOps extends DevOps by integrating security practices into every stage of the development lifecycle. Rather than adding security at the end, DevSecOps ensures that secure coding, vulnerability scanning, and compliance checks occur continuously throughout development. Now that we've covered the application development methodologies, let's cover some additional development concepts. Several foundational concepts help support all application development methodologies. Requirements gathering. Requirements gathering identifies what the system must do to meet stakeholder needs. It includes interviews, surveys, use cases, and requirement validation. Prototyping. A prototype is a simplified, early version of an application used to test ideas, gather feedback, and refine requirements before development begins. Version control. Version control systems, such as Git, track changes to code and support collaboration, branching, merging, and rollback. Testing. Testing evaluates the quality, functionality, and performance of an application. Common testing types include unit testing, integration testing, system testing, user acceptance testing, and regression testing. Maintenance. Maintenance includes updates, bug fixes, performance improvements, and enhancements after the application is deployed. Change management. Change management ensures that modifications to an application occur in a controlled, documented, and reviewed manner. Change management protects application integrity and prevents disruption. And now let's explore when application development methodologies are used in GIS. In GIS, application development methodologies are used when building custom GIS tools, web mapping applications, enterprise geoprocessing services, field-to-data collection apps, automated workflows, and extensions to desktop GIS software. Now you know everything I learned about basic application development methodologies to easily pass the GISP exam. Don't forget to thumbs up and subscribe so I can keep helping people pass the GISP exam and build the rewarding careers in GIS that they deserve. You can also find everything I learned to pass the GISP exam in my book, The Ultimate GISP Exam Study Guide, available on Amazon. My study guide is a comprehensive, easily understandable, graphical, all-in-one resource for passing the exam. You can find the link to my study guide in the description below. Thanks for joining me, and congratulations in advance on passing the GISP exam.